All right, this is FRQ set 7, numbers 1 and 2. So we start with number 1. The rate at which the rainwater flows into the drain pipe is modeled by this function, RT cubic feet per hour. T is measured in hours between 0 to 8 hours. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by D of T. So R of T is coming in, D of T is going out. All right. There are 30 cubic feet of water in the pipe at T equals 0. How many cubic feet of rainwater flow into the pipe during the 8-hour interval 0 to 8, right? So when you're looking for the total cubic feet of water, you are looking for the integral of the rate at which it comes in. So you simply take this rate and you go integral 0 to 8 RT dt, right? And then put that in a calculator and you will get the total amount of rainwater in 8 hours. Okay. Next is the amount, part B says, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. So first of all, you got to figure out how much is in the how much water is in the pipe at a certain time, and then you need to look at the rate at which this is happening to see if it's increasing or decreasing, right? So you are looking at the total amount of water. So how much water is in the pipe? It started with 30 cubic feet of water, and then you are adding in. So adding in 0 to x, x is how many hours this is happening, of r of t, and then minus draining out, so 0 to x d of t. So this is your official equation for the amount of water that is in this drain at a particular time. So then when you're looking at t equals 3, you're looking at what if it's increasing or decreasing. You take the derivative, right? So w prime. So w prime is equal to 30 is my constant, so it goes away. The derivative of integral of RT is RT minus D of T. So W prime at 3, you just plug in T equals 3 into RT minus D of T. You'll get either a positive or negative answer. If it's positive, your rate is increasing. If it's negative, your rate is decreasing. Okay. Part C, at what time between 0 to 8 is the amount of water pipe at a minimum? So you're looking for the minimum of this, right? So when you're looking for the minimum, you're taking the derivative, set it equal to 0. We have W prime. So we have W prime right here, set equal to 0. So basically, it's when R of T is equal to D of T, right? So using your calculator, because this is the calculator portion, you need to figure out when those two equations equal each other, and then find the intersection value and look at before and after to see if it's truly a minimum, right? Remember, if your coming in is bigger than draining out, you have more, so it's increasing, right? And if you're going out is more than coming in, then you're decreasing. So you are looking for a decrease and increase for your minimum for this to happen, okay? All right, next you have last one. The pipe can hold 50 cubic feet of water before overflowing for T is greater than 8. Water continues to flow in and out of the pipe at a given rate until the pipe begins to overflow. Right, but do not solve an equation involving one or more integral that gives time w when the pipe will begin to overflow. So your water cannot exceed 50 cubic feet of water, right? So at any certain point in time, your water that is being held in a drain pipe is 30 plus integral 0 to x r of t minus 0 to x d of t, and you want to see when it equals to 50 cubic feet of water. Because once it's past that, then it begins to overflow. So that's how you would solve for t if you are looking for the answer. Okay, all right. Moving on to number 2. At t is greater than 0, a particle moving along a curve in the xy plane has the position x of t, y of t. So this is a parametric. This is a vector. We're giving the vectors for x and y, right? Okay, so it says find the x-coordinate of the position of the particle at t equals 2. So x-coordinate, it says you start the point at 3, 5. So there is an initial condition, right? You initially start your x-coordinate at 3, and then you need to add on the distance to travel in the x direction. So your x-coordinate will be equal to 3 plus the integral from 0 to wherever x you're going to stop at, or actually where it says 2, right? Sorry, let me go back. It says at t equals 1, that's where we started, and then at t equals 2, that's where we end. Your x value, so cosine of t squared dt, right? And you need to use a calculator for this because this is, you cannot integrate this. You have t squared inside. You don't have u sub for this. So use the math 9 function on the calculator will be nice and simple and quick. Okay, part B. Between 0 to 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point. Okay, so you need to find the slope. Slope is dy over dx, but when we have parametrics, we have dy over dt and dx over dt. So you have to solve for those separately, right? So you're looking for dy over dx, which is dy over dt over dx over dt. So find those two separately, right? And then set it equal to 2, and use your calculator to find those intersection points to solve for t. Okay, part C. Find the time at which the speed of particle is 3. So remember, speed is the derivative of these. So speed is the square root of dy over dt. So dy over dt, where's my dx over dt? Oh, it doesn't matter. I start dx over dt. So cosine of t, this is already v of t, so I don't have to take the derivative again. So speed is the absolute value of the magnitude of your velocity. So it's going to be cosine of t squared plus e to 0.5t squared, right? And then when is this equal to 3? All right, so you have an option. You can go ahead and solve this out a little bit better so it's cleaner, and then set it equal in the calculator to find the intersection points of these two equations. Okay. Last one, part D, find the total distance traveled by the particle between t equals 0 and t equals 1. So it is total distance will be 0 to 1. If you use the speed, the magnitude, you will figure out the total distance because it has no negative value to it. So it's actually much easier to take this right here, the speed equation, and put it in my integral dt, and then put it in the calculator using math9 function and get my final answer. Okay, all right, that's it.